Welcome to Programming Fundamentals. This is Javier Guise. In this video, we're going to be talking about data types and variables. If we go back a little bit, we'll get to remember that a computer program is defined as a set of instructions, just a set of instructions, and that basically will let us think that a recipe is actually a program. And if we remember that a recipe has ingredients, we know that we need a particular type of ingredients and a particular amount of ingredients as well. In terms of similarities with a program, we also have ingredients in code. Basically, we need the variables. We need a particular amount of them, and we need different types of variables at the same time. We've been using variables even using a spreadsheet. Every single cell in a spreadsheet is actually a variable. What can we do within a cell? Well, you can store data, of course. You can store numbers, you can store text, you can store graphics, and every time you want to provide or make a reference to a cell, well, you already have that uh, term already in place because all you need is the column and the row. So for instance, in this example, we have A1. So that cell, it's in fact a variable. And we can store, again, numbers, text, or graphics, or something else. And we can also rename that cell with a different name. That way, rather than using the reference A1, we can say, for instance, tax, solution, volume, or anything we want. The problem with spreadsheets is that every single cell is just the same. All of them are cells. They have like equal conditions, and we can do whatever we want in every single one of them. So there's no special treatment or anything like that. But in code, we have a different situation. We need to have, of course, a way to name those variables just like cells, but it's more similar to a game, for instance. We have different players and we need to name those players. We can name them Jeff, Tony, or Sarah, but at the same time, they play a particular position that is different among each other, and every position has its unique value within the whole team. The same thing goes with variables. We can have different variables, each one of them will have a different name, but at the same time, every variable will have a particular responsibility or action within the code. Now, those variables, once again, will be storing data, and basically we have different types of data. So if we get to do some research on those, what will we find? Well, what about we doing that research by ourselves, or maybe we can team up with someone that we have nearby, and we may be able to spend a little bit of time on it. So go to the web, go to the library, and do some research. I don't know, let's say 5 minutes. And once you're done researching on data types for C++, just come back and we will continue this video. So you're done. Great. So let's continue here. So you found something like this, right? So you get a huge table with a lot of data types. We have something that we call char, int, float, but that's not it. When we are talking about char, we have signed char, we have unsigned char, we have int, short int, long int, unsigned int. So there are so many options here, right? What can we do with all that information regarding data types or variables? Well, we'll see. Trying to provide an analogy with all those data types, think of a variable as an envelope where you can store data, right? And in terms of envelopes, we have so many of them. We have them blue, red, pink, white, small, big, narrow, huge, wide, and each one of them will provide a particular service based on whatever you want to store and how much you want to store in those. It's the type of envelope that you're going to be using. So it's the same thing with variables. And at the same time, once you get to decide for a particular data type for one variable, it will cost you something. In what case? Basically in envelopes, well, it will cost you money, right? Just to buy one of those, or you want to send them to mail, it will cost you money. And it's different if it's a small envelope or a big envelope, if it's a heavy one or not. When you're using variables with a particular data type, what will cost you is, first of all, how much memory you will need to invest for that size of data type. And at the same time, you will inherit some restrictions or situations in the way you'll need to use those variables. That's something that will cost you when you decide for a particular data type. Now, once you have a data type decide, definitely you need to name your variable. And the rules for construction of variable names goes from lexical, syntactical, even semantics, based on which characters can be used to form the name, or once you use the name within a statement, within an instruction, there's a particular order that needs to be followed. And even when you follow that order, there are several conditions that needs to be met in order to say that that instruction is well formed. And finally, we also have something that we name the code standards, and we'll see a little bit of them later on. For instance, let's say that you need to store something, and well, what do you want to store? You need to store numbers, you need to store text. Let's say about numbers. It's a number, a small number, a big number with sign, without sign. It has a decimal point. I mean, it's a floating point number. Or in case it's a text, it's one character. It's a paragraph long. It's a page long. So once you get to identify how is the data, you need to pick up the right data type, the one that you are willing to pay for it. And let's say that you select numbers and you don't want to be using floating point numbers, just integer numbers. Then you can use a data type named int, short for integer. So, and that's the most common data type when you start coding. And once you say, okay, I've decided for integer numbers and the data type is going to be int, so we need to name the variable for that data type. So now you know the size of the envelope. Now you need to pick a name for that envelope. And what I'm saying here is, let's say that you need to move from one house to a new one, and you have some books. So you put all those books inside the box. That box can be named, for instance, X if you want to, or you can name the box books. It's up to you. What would you pick in this situation? Well, I think you will pick books. Why? Because it makes more sense. It's going to be easier for you to identify that box. I mean, when you only have one, maybe that's not a big of a problem, but when you have several boxes, it's easier if you have those boxes properly labeled, right? It's the same thing goes with envelopes, or the same thing goes with variables. So let's say that you want to store someone's age. Well, so you can use the variable name just like in math, right? X, Y, Z, F, G, whatever. Or you can use the label of age. That's right. You can name your variable age, and that means something because you're going to be storing an age, of a person. Now, based on, are you gonna um, store the age in text or in numbers? Because in both cases, the variable name age lets you know that it's going to have store the age of a person, but that's all you know. So in terms of standards, it helps you out applying like a small rule. Once that you identify the right data type, then you use the first letter of that data type and use it as a prefix for the variable name that you selected. So in this case, if I want to store the age of one person in numbers and you already selected the data type int, then the variable name will end with the name of age. I for integer, age for the meaning of whatever you're going to be storing there. Does it make sense now? So in this example, you can see something like gender. So you're going to be storing, as you can see, it starts with C. That means that you're going to be storing one character. So basically, you're going to be storing F for female, M for male. So it, once again, makes sense. We're not going to be storing the whole text female or male, or we're not going to be assigning a number for female or another number for male. It's just a character. Then in the other example, height, it's the height. D, it's for double. That means that it has a decimal point. It's a floating point number, basically. And finally, we have another example with the variable name of nice person. Since we're assigning a value of true or false, that means that it's a Boolean data type. That's why it starts with B. Now, as you can see, every single variable name will start with a lowercase, and afterwards, every single word will start with a capital letter. When you see age, gender, or height, it's a one-word variable. But nice person, it has two words, and every word, it's all full of lowercase letters except the first of each word. Now, the idea of variables is to store data. How are we going to do that? Well, just like in a spreadsheet, you're going to be using an equal sign, and later on, you're going to be providing the right value that matches with the data type that you selected. And everything that you assign to a variable is going to get stored inside of that variable. And that variable is nothing else than some space in RAM. That's it. When you declare variables, you can be declaring one variable per instruction. And as you can see from this format, you can have the data type, the variable name, the equal sign, and a value. And at the very end, it has a semicolon. That's how you end a statement. So in each one of these four examples, all of them ends with semicolon, and that's one way for you to declare variables. In this case, you are declaring the existence of a variable, and at the same time you are providing an initial value. Now, every data type will cost you space in memory. For instance, an integer will cost you 4 bytes, where char costs you 1 byte, double costs you 8 bytes, and Boolean costs you only 1 byte. So when I mention about the cost for every variable, then that's one part of that cost. So once you select a type of data that you want to store, you may need to think, okay, so when I want to store numbers, sometimes numbers can be stored in 1 byte, 2 bytes, 4 bytes, or 8 bytes. Which one shall I be using here? Now, when you declare variables, as I said before, you can assign an initial value right away in the same instruction. But guess what? You can do that later on. So at the first stage, you can declare a variable just with data type and a variable name, and of course ending with semicolon. And in later on in some other instructions, you can assign a value to those variables. It's up to you. Okay. Now, another way to declaring variables is that rather than using one instruction for declaration of variables, when you are using different variables with the same data type, you can group them together in one single instruction. So in this particular example, you have age, amount, and count. You have three instructions for three variables. Only one of those three instructions provides an initial value, for instance. So rather than having just three lines or three instructions, you can use only one because, as you can see, the three of them are integer. So the way to group them together is just to include them in the same line, separating every variable name with or without initial value based on each case, separated by commas. And that's basically it. Now, the assignment, it's quite easy. Basically, you have the variable name, you provide the symbol, the equal sign, and then you provide the value, and you end with semicolon. We already said that. But the thing is that what you can assign to a variable is not only a number, a constant. You can also use another variable since both of them are, let's say, envelopes. Basically, what you're seeing here is that the content of the envelope on the right will be copied, not translated, just copied from one envelope to the other one. That way, both of them will end up with the same value. Or you can do the same thing as in spreadsheets. Rather than assigning just a number or the reference of a cell, you can create what we call an expression using different symbols, parentheses, and different operators, and the result of the whole thing will be the actual value that it's going to be assigned to the variable. So all that is what we call an expression. And what is an expression? It is nothing more than a combination of symbols with variables, operations, functions, and so many other stuff. But don't worry, at the very end, that expression needs to end up with a particular type of value that can be assigned to that variable with that data type. But we'll see about that in another video. For now, what you can do is do some research on expressions, and that will be it.